The Norwegian company Thermtech is the owner and supplier of the thermomechanical cuttings cleaner technology, or in short, TCC, a patented and advanced thermal desorption technology able to treat various kinds of oily sludge. The company's head office is found in Paradis, located halfway between Bergen City and Bergen International Airport, with easy access from most large cities in Europe. The TCC is a very gentle method for separation of oily drilling waste into useful products, securing the reuse of the highly valuable base oil used in oil-based drilling mud, normally referred to as OBM. For that reason, a TCC operation is also commercially beneficial compared to other technologies or methodologies. In most jurisdictions, there are restrictions on how to deal with waste from drilling operations. Typically, there are limitations on discharging the waste to sea. The tendency is that these restrictions are further tightened as the environmental concern increases. There are various treatment options for this waste, like injecting it into a subsea well, controlled landfill, incineration, and bioremediation. With the increased focus both on pollution and on efficient use of natural resources, the global trends move towards separation of the components in the waste for useful purposes. The TCC fits well into this picture. The recovered oil can be used as a component in new OBM, and the recovered solids can be used for various construction purposes. TCC units are in operation in Norway, the UK, the Netherlands, Nigeria, Egypt, and Kazakhstan. New units will be installed in Russia, Turkmenistan, and Germany. By the end of 2008, at least 23 TCC units will be available for handling approximately 600,000 tons of drill cuttings in Europe, Asia, and Africa each year, contributing substantially to a cleaner environment and a more sustainable society. In a lot of situations, TCC treatment can also prove to be the cheapest due to the high quality and value of the recovered oil. Among Thermtech's customers, you will find companies like Miswaco, Halliburton, SCOMI Oil Tools, and Total Waste Management Alliance, referred to as TWMA. TWMA is currently Thermtech's largest customer, with operations in Scotland, Norway, Egypt, and Nigeria. TWMA is offering TCC treatment offshore under the brand name TCC Rotomill. Offshore TCC treatment will soon be offered by other Thermtech customers. Thermtech's vision to set the global standard for treatment of oily drilling waste is about to come true, thanks to the uniqueness of the TCC technology. The TCC is heating the waste differently than other thermal technologies, and this fact leads to a smaller footprint, easier mobility, a safer operation, and a higher quality of the output streams, most importantly the oil. Let us now show you how it all works. The purpose of a TCC unit is to convert hazardous oily waste into useful products. The process consists of some main process steps: a feeding system, a heating process, often referred to as the mill or hammer mill, equipment for further cleansing of oil vapors from the mill, and condensing systems for oil and water. All functions in the process are controlled by an advanced PLS system, and the manpower needs are low compared to other methods. A typical drilling waste will contain 70% mineral solids, 15% water, and 15% oil, percentage by weight. This rather sticky mass is loaded into a feed hopper. Below the hopper, a double piston pump transports the waste into the next process step efficiently. The key component in a TCC is the process mill. In the TCC, kinetic energy is transformed to heat through friction created in the waste itself. This is the main difference between a TCC and other thermal technologies based on indirect heating. The core benefits of the TCC are all related to this difference. A drive unit, typically with an effect of 700 kilowatt diesel or electric, sets a series of shaft-mounted hammer arms in motion inside a barrel-shaped vessel. Before processing starts, there are only dried solids in the vessel. The motor will make the shaft with the hammers rotate. The solid particles will then be forced towards the inner wall of the stator, where the kinetic energy from the rotating arms will be transformed to heat by friction. When the unit has reached a preset temperature, waste is automatically fed into the reaction chamber. The waste is heated by the already heated dried solids. The solids in the waste will add up to the already present solids, and the oil and water will be heated and evaporated instantly. The solids are discharged from the chamber through an automatically controlled discharge valve designed by ThermTech, securing both an efficient discharge without leakage of oil going out or oxygen coming in. The hot solids are then normally transported through a transport screw, cooling the solids to an acceptable temperature. The solids are then re-wetted to avoid dust from the storage tank. Alternatively, the solids can be stored dry. The choice between the options depends on what is later to happen with the solids. A small amount of solids will be carried by the vapors out of the process mill. For that reason, the vapor stream will pass through a cyclone where most of the solids are taken out. To secure maximum quality of the oil, the vapors will also pass through an oil scrubber, where the remainder of solid particles are separated from the vapor stream. The next step is a condenser for the oil, where the oil vapors are brought back to high-quality liquid oil. Afterwards, the water is condensed to liquids. A small percentage of the oil, that is some of the lighter fractions, will not be condensed in the oil condenser and is taken out from the water in a traditional oil-water separator. Although the process is simple in principle, there are a large number of elements in the process that need to be properly measured and controlled, like temperatures, load, and pressure. The control system secures everything works as it is supposed to, and if it does not, the default is either corrected or the equipment is stopped automatically in a safe and sound manner. The control system will normally be installed in a separate control room, but warnings and alarms will be given when the system requires human attention. This means that there is normally no need for permanent staffing of the control room. The control system can also be monitored, operated, and maintained from distance through Internet. The control systems will include a rather extensive report function, enabling easy tracing of historical data like uptime and performance. Most of the benefits with a TCC are related to the way the waste is heated. The footprint is small because it is in fact the surface of the many billion small solid particles that transfers heat to the liquids. The total surface inside the process mill is similar to the total surface of the enormous heated surfaces of an indirect dryer. The startup is quicker. When you switch on a motor or engine of 700 kilowatts, it soon becomes rather hot inside a 1 meter by 1 meter chamber, with particles constantly colliding. The process loses less energy to the surroundings because there are no large heated surfaces. It is safer because there are no oxygen sources worth mentioning. It is simply much easier to protect by insulation and simple routines. The strongest commercial argument for choosing the TCC technology relates to the quality of the recovered oil. That is proven to be higher in the TCC than in any of the competing technologies, and that is logical. In the TCC, the retention time for the oil under high temperature is maximum a few seconds before it leaves the chamber as vapors. In the indirect heaters, the waste, including the oil, is heated slowly, like water in a kettle. In addition, the temperature of the heating medium in an indirect dryer needs to be higher than the evaporation temperature of the oil, meaning that the oil is also influenced by a higher maximum temperature. In the TCC, the hottest spot in the process is actually the waste itself.